Hi guys, this is Mohammad P, a tutor on Chegg.com. Today we are talking about substitution method for integration. So let's just start with this example. Integral of 3x squared plus 1 to the power of 3 times x dx. So we are going to take this integral. As you see, it looks a little bit complicated, but if we let u equal 3x squared plus 1, and then if I take the differential of both sides, so du is going to be 6x dx. So I need to find a substitution for each part here in terms of u. So I chose this part as u. Now I'm looking for a substitution for the x dx. If I divide the both sides here by 6, I would get a substitution for x dx in terms of u. So this is going to be 1 over 6 du. Now I can take the integral of u to the power of 3 times 1 over 6 du, which is 1 over 6 integral of u cubed du. And that's equivalent to 1 over 6 u to the 4 divided by 4 plus c. That's going to be u to the 4 24th plus c, and the u is 3x squared plus 1 to the power of 4 24 plus c. So basically, when you're done with the integration, you have to substitute back for u, because the original problem is in terms of x, and finally you have to have everything in terms of x as well. So let's do another example. So integral of cosine x sine x dx. So you need to always choose u as a part that you have its derivative inside of the problem. So basically I choose the u something that I already see its derivative in the problem. So if I choose sine x as u, I know the derivative of sine is cosine, and I already see this here. So cosine x dx, taking the differential, it gives me actually a substitution for cosine x dx in terms of u. So the whole problem becomes u du, and this is equivalent to u squared over 2 plus c. Now I'm done with the integration. I need to plug them back and substitute back everything in terms of x. So it's going to be sine squared x over 2 plus c. Now let's look at the integration which is involved with the lower and upper limits, basically definite integrals, and also I want to involve u substitution. So let's say from 1 to 3, x squared e to the x cubed plus 1 dx. So if I choose u as a x cubed plus 1, I see the derivative of this, not the whole part of the derivative, just a portion of it, which is x squared right here. So if I choose u equal x cubed plus 1, then du is going to be 3x squared dx. So I'm taking the differential of the both sides. Du is 3x squared dx. Now I'm looking for a substitute for x squared dx, and that's going to be, if I divided both sides by 3, so 1/3 du is going to be x squared dx. So I can find a substitution for x squared dx in terms of u. Now the key thing here is the limits of integration. These limits belong to x, but right now I'm trying to take the integral with respect to u. So we need to use the relation between u and x to convert these limit of integration of x to the limit of integration of y. So if x is equal to 1, let's see what happens to u. U is going to be 1 cubed plus 1, that's going to be 2. And when x is 3, u is going to be 3 cubed plus 1, that's going to be 28. So this integral becomes 2 to 28 e to the u 1/3 du. So instead of x squared dx, I'm putting 1/3 du. So this goes outside, it's a 228 eu du, and we know the integral of eu du, that's itself, so it's 1/3 e to the u from 2 to 28, that's going to be 1/3 e to the 28 minus e to the 2nd. That's going to be the answer for this. So I've already shown the indefinite and definite integral involving u substitution. So if I want to summarize it, you should choose the part in the problem as u that you see its derivative already inside the problem. And then you set that part equal to u, you take the differential and you find the substitution in terms of u for the other part, and then you totally convert the whole integration in terms of u. And after you got the result in terms of u, you have to substitute back and put everything in terms of x again. I hope that you all enjoyed and you learned a lot. So till next video, I wish you the best and have a wonderful day. Goodbye.